An eclipse of the sun occurs when all or part of the sun becomes dark. An eclipse of the moon occurs only during a full moon, when all or part of the moon becomes dark, and this will be explained in more detail near the end. When the sun is completely covered, it is called a total solar eclipse and can look like this. When it is partially covered, it's called a partial solar eclipse and can look like this. When the moon is completely covered, it is called a total lunar eclipse and can look like this. And this eclipse shows red and not dark, and that'll be explained also near the end. When it is partially covered, it's called a partial lunar eclipse and can look like this. A good video on solar and lunar eclipses made by the National Geographic can be found on YouTube. Here is the title that should get you to it. To get the lunar eclipse, just replace solar by lunar. In this section, here's a short clip showing another type of eclipse called an annular eclipse.
An annular eclipse occurs when the moon passes directly in front of the sun, but the lunar disk is not quite wide enough to cover the entire star. At maximum, the moon forms a black hole in the center of the sun.
Eclipses from our point of view on Earth occur when the alignment between Sun, Moon, and Earth is just right. Here is what I mean for a solar eclipse when the moon is in front of the Earth. Just as we say that new technology eclipses older technology, we can say that in a solar eclipse, our moon is eclipsing the sun. We can also say that the sun is being eclipsed by the moon because the moon is blocking the sun, partially or fully. It will cast shadows on Earth like this. At this point, the darker shadow is called the umbra, and the lighter one is called the penumbra. As the moon continues its way around Earth, the shadows cross the Earth. People who are in the path of the umbra will see the total eclipse. This path is called a path of totality. Here is a good animation of the 2017 eclipse, which I happened to see near Kansas City, Missouri at that time. The moon's shadow races across the Earth. The small black circle is the umbra. People in this area will see the total eclipse. The lighter penumbra surrounds it. The red path is the path of totality. Although this simulation is speeded up, the time at the bottom left correctly shows that crossing the land takes about 4.5 hours. People in the umbra see totality for only 2 to 3 minutes. This is because the umbra is so small. In the lunar eclipse, the Earth's shadow is so large that people can witness the eclipse over several hours. In the eclipse of the moon, where the moon is behind the Earth is getting in the way of the moon. That is, the moon is being eclipsed by the Earth. But since it's the moon that's moving into the shadow of the Earth, it's really the moon's fault for being eclipsed. Anyway, as the moon moves in its orbit, it enters the two shadows of Earth. First the penumbra, then into the darker umbra, giving first a partial eclipse, which then becomes a total eclipse, and then exits the penumbra and continues to orbit the Earth. Let's compare the two eclipses here. Notice the smaller shadow of the moon on Earth during the solar eclipse. In a lunar eclipse, the shadow of Earth on the moon is larger, which means more people are likely to see a lunar eclipse than a solar eclipse. Notice also that the shadows in the eclipse of the sun are temporary and formed by the movement of the moon. In the eclipse of the moon, the shadows are of the Earth and are permanent as the Earth orbits the sun. Now, you might ask, since the Earth's shadows are permanent, why don't we see a total lunar eclipse every month? The answer lies in the plane of the moon's orbit. Here is the moon's orbit around Earth. Notice how it is aligned nicely in line with the sun and Earth. That's what I meant earlier by saying the alignment between sun, Earth, and moon must be just right. On the day when the moon is following this path and there is a full moon, that's when the lunar eclipse is possible. Why don't we get a lunar or a solar eclipse every month? The answer is that the path of the moon, its orbital path, is tilted with respect to the sun. Here is a picture showing it. This means that most of the time the moon passes over or under the orbital plane of the Earth, thus preventing any eclipse from happening. Let me show you the mechanics of what this means. Although we know that the Earth revolves around the sun, from the Earth's point of view, we can see the sun as revolving around us. So let's draw the sun's path around us. This path is called an orbit, and this surface that contains the orbit is called the orbital plane. Both are imaginary constructs so we can talk about things. Every orbiting object has an orbital plane, but to keep it looking cleaner, I will leave out the shading. We understand that every orbit is part of an orbital plane. At the same time, the moon also revolves around us like this. But notice that the orbital plane of the moon is tilted about 5 degrees from the sun's orbital plane. The important point here is that there are 2 points where the 2 orbits intersect. They're called nodes. I'll mark them with red dots. If the moon happens to be at one of these nodes and at the same time is lined up with the Earth and Sun, then we'll have either a solar or a lunar eclipse. Let me show this with the sun at the center. Here's the Earth and the plane of the Earth's orbit. This dashed line shows Earth lined up with the sun in Earth's plane. Now we add the moon's orbit, and I'll let this star represent the moon in its orbit. The moon's orbit is shown tilted 5 degrees from the plane of the Earth's orbit. Now, when the moon reaches either of the red nodal points, and if the moon is in the position of the dashed line, you can see how moon, Earth, and sun are all in line for either a solar eclipse in front of Earth or a lunar eclipse behind Earth. Here is one other position where the moon's orbit intersects with the plane of the Earth. Anywhere else, the intersection does not line up with the sun, as the dashed line shows. Here is a clip that shows the same idea, plus a bit more.
At this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most months. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its annual orbit, those points line up with the sun about twice a year. As the moon passes between the sun and Earth at that time, we get a solar eclipse. And when it's behind Earth at that time, we get a lunar eclipse. But in general, we'll have a few solar and a few lunar eclipses of some sort every year. But you're more likely to see a total lunar eclipse in your lifetime than a total solar one. The totality of a lunar eclipse can last well over an hour, and it's viewable for anyone on the night side of Earth. Totality lasts just a few minutes, and although Earth gets a total solar eclipse every 18 months on average, each one is only viewable by less than 0.5% of Earth's surface. Eclipse chasers travel all over the world to put themselves in the path of that shadow.
However, a full moon can still occur and is a very common and often beautiful sight. I will finish with another potentially puzzling question. Here is a total lunar eclipse showing a beautiful reddish color. How can this be when the moon is in the Earth's shadow as shown here? Umbra means shadow, and shadow implies absence of light. So how can the moon in this position be reflecting light back to the Earth? When light from the sun passes through the Earth's atmosphere, the blue light continues straight ahead, where it's actually scattered away, but the red light gets refracted onto the moon's surface. And that light is then reflected back to the Earth and into our eyes. At night, the Earth's shadow goes out into space, which obviously we can't see the shadow, so I've made an outline here to show how the moon enters the shadow at the beginning of the eclipse, creating the total eclipse, and then how it leaves the shadow at the end. Probably know that total eclipses of either kind are not that common. This chart shows some upcoming lunar eclipses visible from North America, and this one for solar eclipses. As you can see, they are mostly single instances, except for 2018, and then not every year, so they are relatively rare occurrences. Let's look at a summary now between the lunar and solar eclipse. First of all, what are we looking at during a lunar eclipse? Well, the moon. And during a solar eclipse, we're looking at the sun. What is happening during a lunar eclipse? The moon is passing through the Earth's shadow, and in the solar eclipse, the moon blocks the sun. And by the same token, in the lunar eclipse, it's the Earth that blocks the sun. What is the phase of the moon during a lunar eclipse? It has to be a full moon. And in the case of a solar eclipse, it has to be the new moon. Is a lunar eclipse dangerous to observe? No, it isn't, because we're looking at reflected light off the moon. In the case of a solar eclipse, it is dangerous unless you're looking at totality, in which case you can take off the glasses for a couple of minutes, but otherwise it is dangerous to look at the sun. When do we observe a lunar eclipse? At night, and a solar eclipse during the day. How often does a lunar eclipse occur? About once a year for a given place on the globe. Now, solar eclipses are rather rare because the visibility of the area is very small. So that sums it up, and that ends this video on eclipses.